Hello, everyone, and welcome to this occasional series of entrance exam questions. And today we're going to look at a question from the MAT, and this is from 2018, question 1 section. This is worth 4 marks, so on average they should take about 4 minutes. But this is a particularly tricky one, so let's see. A particle moves in the xy plane, starting at the origin. At each turn, the particle may move in one of two ways. It may move 2 to the right and 1 up. That is, it may be translated by the vector 2, 1. So I'm going to rewrite that as a vertical column vector. And then similarly, it may move in one to the right and 2 up. That is, it could move 1 to the right and 2 up. And it says, what is the closest the particle can come to the point 2575? So, first observation is that the extremities will be such that you either go 1 up and 2 across, or you go 1 across and 2 up and keep going. So in other words, you'll end up with something like, if you're going here, if you're moving 2 to the right and 1 up, and then you start 2 to the right and 1 up, and you keep going like that, or you go 1 and then 2 up, 1, 2 up, and so on. But they will always end up on 2 particular lines. So it's worth drawing a diagram here. We've got, it's always going to go up and to the right. So if it's going 2 across and 1 up, then it's going to end up on the line here. This is going to be y equals a half x, or it's going to go 1 to the right and 2 up, in which case we will get another line going through the origin, but steeper, and this one will be y equals 2x. So let's think about the point now, where the point 2575 lies in this diagram. Well, if we're going 25 across, let's say that's here, then this line would be 2 times 25 is 50. So if it was 250, it would be on here, but it's not. It's 20. Sorry, if it's 2550, that would be on the line, but it's not. It's 2575, so that's going to be above the line somewhere. This is the point 2575. Now we want to find the shortest distance from this to some point that is on this line. And it might not be perpendicular. It's not necessarily going to be the case. But we need to think about the circle that goes round here and what the radius of that circle might be, because it does touch this in one place only. So if we're going to think about the circle and it hitting this line here, then we've got 2 pieces of information that we can start with. We certainly know that y equals 2x. This other line is completely redundant. We're focusing on the steeper of the 2 lines. So we've got this, and we've also got some information about the circle, which is x minus 25 squared plus, now instead of y minus 75, I'm going to write 2x minus 75 squared. And this expression here, whatever it is, we want it to be as small as possible. We want it minimized. So we're really talking about differentiating now. So let's talk about differentiating. Let's differentiate this. We get 2x minus 25 plus 2 lots of, and then there's a 2 in front of that x, so that comes out as well. 2x minus 75. And all this we want to set to 0 to find the minimum. So we've got 2x minus 50 plus 4 times 2 is 8x. 75 times 2 is 150 times 2 is 300. Minus 300 equals 0. Collecting our x's, we've got 10x and adding 350 to both sides gives us 350. Dividing by 10 gives us a value of x equals 35. So our coordinate for the x on the line is 35. So clearly, because it's on the line, the y coordinate that we want is twice that, 70. So we want to know the distance now between our point 2575 and this point here 3070. So we can do that with Pythagoras. Distance equals the square root of the difference in the x values is 10, 35 minus 25, and the difference in the y values is 70 to 75, which is 5. So that's 125. The square root of 125 equals 5 root 5. So that's our answer. Let's have a look. Is it in the list given? Yes, it's this one here. And we're done.